Okay, so we are on the final question of Chapter 9 here, in which we have been dealing with support vector machines primarily, or support vector classifiers. This question is just really a continuation or another instance of what we've seen so far. So we're looking at a data set that is contained in the ISLR2 package, and the data set is called OJ. So we have parts A through H, and roughly we're going to fit and then look at the training and test errors of different support vector machine motifs, so a linear, a radial, and a polynomial. Okay, so the first thing we need to do is to get the ISLR2 package loaded up. And then part A is we're going to create a training and test data set from our OJ data set. And so I'm just calling OJ, the data set OJD here. And then I am randomly sampling 800 cases or rows from the data set. And then I am using those randomly sampled cases to comprise my training data set, and then everything else is my testing data set. And so I've also just called up head dtrain here just so we can see what it looks like, or what the data set looks like. Okay, so now in part B, we're going to use a support vector classifier. We're going to use a linear SVM, I guess, is how I think about it. Setting the cost function to 0.1, where we're trying to predict purchase. And so purchase is over here in the data set. It's either CH or MM. I'm sure that we could look at the information sheet for this data set to know what those meant, but I don't really care here. So we load the E1071 package because that's where our SVM commands will come from. So I'm calling this first model MB because we're in part B and we're using SVM. So purchase is being not really regressed on, but we're trying to predict purchase based on the period means every other variable in the data set. And I'm using the training data, and I have my kernel is linear and the cost is 0.01 as specified in the question. And then it says to use summary function to produce some of the summary statistics. This is what we get here at the end. So there you go. This isn't in itself all of that telling, but in part C we look at the training error and test error rates. And so for training error, I am making predictions, and then I'm looking at, then I create a table that compares what is predicted versus the actual data. And then, there's different ways to get training and error rates, but then I am taking the table, and you can see the table right here, and I am just taking the numbers that I got wrong, which is these off diagonal terms, the 63 and the 69, and dividing that by the total number of entries. Okay, so I do that for the training data as well as for the test data, where the only difference is now instead of predicting dtrain, I'm predicting dtest, the test data. And here we have the confusion matrices, or the tables comparing what was predicted versus what was actual, and the little number here at the bottom is the error rate, right? So on the training data here it was 16.5%. On the test data it was 18.5% roughly. Now for part D we're going to do something similar, but instead of just testing one cost function, here it was 0.01, we're going to use the tune function instead of the SVM function. We're going to use the tune function, and we're going to test a bunch of different possible costs. So between 0.1 or 0.01 and 10, and so these are the values that I chose to test here, okay? And so we run that, and we can see, which one had the optimal cost, or at least optimal in the options that we've selected here. And so, when I run summary, it tells me which one was the best. In this case, it was 0.3. If I run this a few times, sometimes it alternates between the cost being 0.3 best versus, and sometimes it's 10. So there you go. Okay, so there's that. And then just right here, I am preemptively selecting the best model because I know that we're probably going to use it going forward here. So to get the best model, which again is where the cost is 0.3, I can just call up MD and pull out best model. Okay, and I'm calling that MD best. All right. So in part E, we're going to use the best model from what we just found to find the training error and test error rates. Okay, so this code block right here is just like what we did up here, but instead of using model MB for everything, I'm using model MD. So I won't go back through the code, but you can see that the training error rates and the test error rates here. So again, previously we saw that the training and test error rates were 16.5 and 18.5. Here, using the optimal cost function, we have 16.75 and 17%, right? So an improvement on the training on the test data error set or error rate. Okay. Now in part F, we're going to repeat parts, B through E, but now instead of using a linear classifier, we're going to use a radial, so a radial kernel. Okay. And we're supposed to use the default value for gamma. I used a bunch of different values for gamma. I'm just going to keep it like that because why not? So anyway, so we now, instead of using the SVM function, again, let me say this. I'm not going to do parts B and C where we just set the cost function to 0.01 because I don't really see the purpose in doing that because we're looking for the best models here, or at least the best of the things that we try. So I'm skipping parts B or repeating B and C, and I'm just going through D, E, right, where I test a bunch of different possible models with the tune function. You're free to do whatever you want, of course. So I run the model, I find the best of those, and then I find the training and test error rates. Okay, and so if I go all the way to the bottom here, we have those. So on the test data, on the training data, we have an error rate of 15.6% and 18.5% for the test data. And then in part G, we're doing yet another kernel. Now we're doing polynomial kernel, and we're setting degree 2. So we have all this. Do the same thing. Look at the training and test error rates, and here I have on the training data, I have 15%, 15.1% versus 18.1%. And then in part H, we're supposed to say which gives the best results. Well, I think that what we want to do is compare the test error rates. And so I could scroll back through all of these, but the one that did the best on the test data was the very first one that we did, which was the linear kernel. Okay? So that is part H, and that is also all of chapter 9. And so then we move into chapter 10, which is on deep learning and neural networks. And so I will see you then.